Veterinary medicine has quietly become a hotbed of innovation, often serving as both proving ground and parallel field for biomedical breakthroughs. But while stem cell injections and laser therapies get the spotlight, an unlikely contender is beginning to show up in the treatment rooms of animal hospitals: yogurt-derived extracellular vesicles, EVs, and yogurt-based hydrogels. Yes, the same humble fermented dairy product that comforts human guts might soon be playing a major role in regenerative therapies for dogs, cats, horses, and beyond, from wound healing to orthopedic repair. The idea isn't as outlandish as it first sounds. In fact, yogurt is emerging as a powerful biological toolkit, offering probiotic-derived nanovesicles and bioactive protein matrices that exhibit anti-inflammatory, antibacterial, and regenerative effects. When adapted for cross-species use, these components can offer safe, low-cost, and effective options for animal tissue repair, especially in species where treatment options are limited or cost-prohibitive. Let's start with wound care, an ever-present concern in veterinary clinics, particularly for trauma-prone animals like horses and outdoor cats. Yogurt-based hydrogels can be formed from casein proteins and probiotic bacterial exudates, yielding a moist, breathable, and antimicrobial wound environment. These dressings conform easily to irregular surfaces, read animal limbs, tails, or ears, and more importantly, they naturally support angiogenesis, reduce pro-inflammatory cytokines, and accelerate epithelial closure, critical for preventing infection and scarring. The probiotics involved in yogurt fermentation, such as Lactobacillus plantarum, produce lipopeptides and bacteriocins that can directly inhibit Staphylococcus aureus, E. coli, and other common pathogens in animal wounds. Now enter the extracellular vesicles, tiny lipid-bound messengers released by probiotic microbes during fermentation. These EVs contain proteins, microRNAs, and lipids that influence cellular signaling. In preclinical models, yogurt-derived EVs have demonstrated immunomodulatory properties, shifting macrophages from a pro-inflammatory M1 state to a healing-friendly M2 profile. This immunological tuning could be hugely beneficial in post-operative recovery for animals, reducing the reliance on steroids or antibiotics. Veterinary use cases don't stop at skin. In bone regeneration, yogurt-derived components are being tested as part of injectable gels or scaffolds to treat fractures or joint degeneration. In species prone to osteoarthritis or slow-healing bone injuries, think older dogs or performance horses, dairy-derived hydrogels enriched with yogurt EVs may serve as biological glues and stem cell boosters, helping drive both osteoblast differentiation and vascular ingrowth, two key steps in stable bone healing. Another promising avenue is gastrointestinal recovery, particularly for animals recovering from intestinal surgery or chronic inflammation like feline IBD or canine colitis. Oral delivery of yogurt EVs in encapsulated form could modulate gut inflammation, repair intestinal lining, and rebalance the gut microbiota, all without disrupting the delicate digestive systems of these animals. And because yogurt and its byproducts are generally recognized as safe, GRA, they can often be used without extensive regulatory hurdles that would apply to synthetic or genetically modified therapies. One advantage of this approach is accessibility. High-tech therapies like stem cells or gene editing are still limited to specialty practices and wealthy clients. But yogurt-based biomaterials are inexpensive, naturally derived, and relatively easy to manufacture, opening the door for rural or resource-limited clinics to provide cutting-edge healing interventions. Whether it's a dairy cow with a hoof injury, a dog with surgical stitches, or a parrot with a cracked beak, yes, avian regenerative cases exist. Yogurt-derived therapies offer a species-flexible, bioactive, and scalable platform. Naturally, questions remain. Species-specific immune responses to bovine proteins, vesicle dosing thresholds, and long-term integration of dairy hydrogels into tissue all need further study. But early cross-species trials in rabbits, pigs, and canine models are encouraging, showing no major adverse reactions, improved healing times, and lower infection rates compared to standard treatments. So the next time a vet reaches for a treatment cream or injects a post-op booster, it might just contain components brewed not in a pharmaceutical lab, but in a yogurt fermentation tank. Dairy isn't just about nutrition anymore. It's quickly becoming a regenerative toolset, and animals, just like humans, may soon benefit from its full healing potential. In short, yogurt is going beyond breakfast and bounding paws first into the operating room.